Hi and welcome back. Tonight's notes are going to be on angles and arcs. In circles. Okay, this is on page 66. So angles and arcs in circles. So let's start off by drawing a circle. Okay. And we have a center. Now let's say we have the center and we have radii coming off of that center going to the edge of the circle. Okay. This is what's called a central angle. Okay, because it starts at the center and it's going to the outside. Okay, so the degree of the central angle equals, okay, and then we have an arc. The arc is from where it intersects to where it intersects. So those endpoints, there and there, that is called the intercepted arc. Okay, so where it intercepts that arc, the degree of the central angle equals the degree of the intercepted arc. So if you know one of them, you know both of them because they're going to be equal. Okay, now let's look at a little example of this. Let's say we have that circle. And we know the measure of angle AZB is 110 degrees. What is the measure of arc AB? That's what that means. This means the arc AB. Okay, well, let's put the information that we know. We know this is 110, so I'm going to put 110 here. AZB. And then the intercepted arc, which is AB, from there to there. Well, that's what we're trying to find. Well, again, we know that the degree of the central angle equals the degree of the intercepted arc. So we know the measure of arc AB is going to be 110 as well. Okay, because they're the same. 110's here, so 110 has to be out there as well. If it is a central angle, which that is. Okay? So that's one type of angle, is a central angle. Now, let's draw another circle. And now we have a different type of angle. And it's going to go from the edge of the circle to the edge of the circle to the edge of the circle, like that. And that is called an inscribed angle. Okay, it's inscribed. It's inside the circle, but it's going from endpoint to endpoint to endpoint. Okay, and again, we have the intercepted arc here. Okay, so inscribed angle, intercepted arc. So this time, the degree of the inscribed angle equals, this time it's not the same, it's 1/2 of the intercepted arc. So you take the intercepted arc, divide it by 2, and that's going to be our inscribed angle. Okay. Another way to write this is 2 times the degree of the inscribed angle. Equals the intercepted arc. Okay, so either you take the intercepted arc and divide it by 2 to get this one, or you take this one and multiply by 2 to get the outside. Okay, and now let's do an example of each of those. Okay, so I want you to try those two. The first one, we're given the measure of angle ABC is 60, and I want you to find the measure of the arc AC. The second one, I'm giving you the arc DF is 134. I want you to find the angle of DEF. Okay, so the first one, we know the angle measure of ABC is 60. So we're trying to find the intercepted arc, which is, we're given the degree of the inscribed angle. So I'm going to say 2 times the degree of the inside angle is going to equal that intercepted arc, which means the measure of AC is going to be 120. And then the other one, we're given the intercepted arc is 134. We're looking for this one. We're given this one. That means I'm going to take 1/2 of that 134, and that's going to be the measure of angle DEF, which means the measure of angle DEF is going to equal 67. Okay? All right? Now let's look at putting both of those together. So let's draw a circle. And let's first draw a central angle. So we have center C. Our central angle is going to be ABC. Excuse me, ACB. Okay? So this first angle, ACB, is a central angle. Okay. And then I'm going to draw another ADB, like that. ADB, angle ADB. And what kind of angle is ADB? ADB is an inscribed angle, because it goes from the outside to the outside to the outside. Okay? So if we have this, you'll notice that they are intercepting the same arc. So this right here, AB, is our intercepted arc. And it's our intercepted arc for ACB, and it's our intercepted arc for ADB, right? AB stays the same. So when this happens, If an inscribed angle and a central angle have the same intercepted arc, then the central angle is going to equal 2 times the inscribed angle. Okay, which makes sense because they're intercepting the same arc, and that's the property for getting that intercepted arc. Okay, so that's just a few angles and arcs properties for circles. Thanks for watching.